The winds that sweep across the North China Plain today still carry fine dust from distant deserts. That same dust once drifted over a spring-fed hollow near the city of Shuchang. In that shallow basin, where Ice Age animals came to drink and hunters waited for them, 2 human skulls lay hidden for more than 100,000 years. When researchers finally uncovered them, one after the other, they soon realized they had found something remarkable. The Shuchang skulls preserve a brain case that looks both ancient and strangely familiar. The back of the head swells outward into a bun. The skull vault is long and low, with thick bones and heavy brows. Anyone familiar with Neanderthal anatomy will see the resemblance immediately. Several international studies using detailed measurements concluded that these 2 skulls, Shuchang 1 and Shuchang 2, are statistically closer to Neanderthals than to Denisovans, or modern humans. Although not widely known by the public, the Shuchang skulls deserve attention. They shift the human story eastward with striking clarity, showing that features once thought unique to Europe also appear deep in the heart of China. Their age places them in a warm period when grassland stretched from the Carpathians to the Yellow River, and when climate shifts temporarily turned Central Asian deserts into passageways instead of barriers. Taken together, the evidence raises a bold possibility that a population with Neanderthal traits spread across Eurasia during this hospitable interval, reaching the North China, where they encountered local archaic humans related to the Denisovans. The result may have been hybrid populations with the evidence preserved in bone. The Shuchang site lies in Henan Province, close to ancient channels of the Yellow River. In the Pleistocene, this was a corridor where herds moved between uplands and lowlands. Hunters followed rivers, and flint could be chipped from riverbanks. Excavations at the spring basin revealed traces of intense activity: cut-marked animal bones, stone tools, and fragile pieces of human skulls. Each fragment was carefully mapped, lifted, scanned, and digitally reconstructed so the crania could be studied from every angle. The digital models made seasoned paleoanthropologists sit up, especially when viewed from behind. The rear of the vault is rounded and projects backward. A shallow depression lies above the nuchal lines. The side walls sweep out in a pentagon-like outline. When compared to famous Neanderthal skulls such as La Pharisee or La Chapelle aux Saints, the resemblance is clear. This is not just a case of lookalikes. Neanderthals are recognized not by one feature, but by a whole set of traits that appear together. The occipital bun, a long, low vault, mid-facial projection, a distinctive pattern in the inner ear canals, strong brow ridges, and robust cranial bases. Many fossils show some of these traits, but very few show most of them. At Shuchang, several of these signatures cluster, especially in the posterior cranium, the most conservative and telling part of the skull. The bun is there. So is the suprainiac fossa, an oval depression strongly associated with Neanderthals. The vault is long, low, and archaic, not modern. Add in thick cranial bones and an estimated brain size in the upper range of late Stone Age humans, and the case for Neanderthal affinity grows stronger. Dating places the skulls in late marine isotope stage 5, a warm period between about 125,000 and 100,000 years ago. In northern China, this period shows up in soils, lakes, and dunes. Stronger summer monsoons produced fertile soils on the Loess Plateau, filled playas with water, and expanded steppe grasslands across the region. In other words, it was a time when ecological barriers softened. Westerly winds weakened, the East Asian summer monsoon pushed north, and ecological belts blended across a broad trans-Eurasian zone. If there was ever a window for populations to move eastward from Europe, across Kazakhstan and Mongolia, and into North China, this was it. We often imagine Neanderthals confined to Europe and the Caucasus by ice and mountains. That picture, shaped by early 20th century discoveries, was never the full story. In recent decades, fossils and genetics have shown Neanderthals to be more widespread. They reached the Levant repeatedly for at least 130,000 years. They lived in the Altai Mountains of southern Siberia, where a phalanx bone yielded classic Neanderthal DNA, and their genetic traces remain in living humans, with East Asians carrying slightly more Neanderthal DNA on average than Europeans. All of this paints a picture of a population that was mobile, resilient, and capable of adapting to a wide range of environments. Against that background, the Shuchang crania no longer seem improbable. They start to seem inevitable. If Neanderthal-related groups could reach the Altai, why not continue eastward along the steppe when conditions allowed? Geography also supports the idea. A line drawn from the Altai to the North China Plain runs through the Dzungarian Gate, skims the Gobi, and descends into the rivers that feed the Yellow River. During warm intervals, this route would have been greener, marked by seasonal lakes and grasslands from Kazakhstan to Inner Mongolia. The arid corridor that often divides western and eastern Eurasia would have been dotted with pastures and wetlands. Herds of steppe bison, horses, and wild asses would have found food there, and hunters could follow without fear of starvation. It is not hard to imagine groups of Neanderthal-like humans moving eastward in small pulses, maybe a few hundred people at a time, sometimes scattering, sometimes merging with locals, and leaving behind traits like those seen in the Shuchang skulls. The late Middle and early Late Pleistocene fossil record of East Asia is filled with skulls that are neither fully Neanderthal nor fully modern. Dali, Jinyushan, Maba, Harbin, the so-called Dragon Man. These fossils show a mix of features: large brain cases, thick bones, flat midfaces, wide cheekbones, and unusual details at the skull base. For years, they were seen as evidence of long-term regional populations in China, distinct from but connected to the West. When geneticists recovered ancient DNA from a finger bone in the Altai and named the group Denisovans, the Chinese fossil record suddenly had a likely genomic counterpart. Later, proteins extracted from a jawbone on the Tibetan Plateau confirmed Denisovan identity at high altitude. This was the world the Shuchang people lived in, a landscape where Denisovan-related groups occupied both lowlands and highlands, leaving faint but lasting traces in modern populations from Oceania to the Americas. If Neanderthal-related groups reached North China during this time, contact with Denisovan-related locals would have been unavoidable. Archaeological evidence hints that knowledge traveled as well. Levallois flaking, a stone tool technology strongly linked with Neanderthals, appears sporadically in North China around 100,000 years ago. This does not prove Neanderthal presence, but it reminds us that ideas, like people, can cross continents. At Shuchang, stone tools and butchered animal bones show that people lived around the springs for long periods. They probably dressed in hides, cut with scrapers and awls like those found at other sites of similar age. Stitched skins would have been crucial in the cold winters of northern China. Summers were warm and wet, with green plains and tree-lined rivers. These groups likely moved widely along rivers, camping near water in dry months and spreading out when rains came. To call the Shuchang skulls the first Neanderthals in China would be too simple. Scientifically, they are best described as late Pleistocene archaic humans with many Neanderthal-like traits, especially in the back of the skull, alongside features common in East Asian fossils. Without DNA, we cannot be certain, but the discovery is still powerful because it shows that Neanderthal history was not just a European story, it was continental. It shows that the Denisovan story was not limited to one Siberian cave and a Tibetan jawbone, but extended across the plains where mixed communities could form. For decades, East Asian fossils were interpreted through a debate between regional continuity and replacement from Africa. Genetics has since shown that human history is neither pure continuity nor total replacement. It is braided. Modern East Asians carry ancestry from several streams. Modern humans from Africa, Neanderthal DNA from multiple contacts, and Denisovan DNA from several points of contact. The Shuchang skulls embody that braiding. Their skulls show a Western influence in the back of the head and more local traits in the front. Together, they reflect a blend of lineages. If future studies manage to recover proteins or DNA from these fossils, they may confirm what the anatomy already suggests, that these people were part of a hybrid population. Imagine a winter day near Shuchang 100,000 years ago. A small group approaches a spring they have known since childhood. Among them is a woman whose mother's ancestors came from the west, while her father's roots lie deeper in the east. To her, they are simply family. She carries a child on her hip and a flake tool made from a prepared core. At the water's edge, hunters point to animal tracks, and laughter carries across the reeds. In that moment, Neanderthal, Denisovan, and local archaic are already fused in a single community. The Shuchang skulls remind us that human history was written in corridors, river valleys, and seasonal paths shaped by climate. They mark a moment when conditions allowed movement across northern Asia, and when people carrying a Western signature could stand at a Chinese spring and see themselves reflected. In their anatomy, we glimpse the possibility that Neanderthals, or groups very close to them, once reached North China, mixed with Denisovans, and helped shape the ancestry now found in billions of living people. This is not just a footnote to European prehistory, it is a new chapter in Asia's deep past and in our own. Thank you for watching.